Hi, this is Bob Geiger from STW. Today we're going to be talking about STW's Telematics Solutions, both from a hardware and software perspective. STW is an electronics manufacturer headquartered in Germany. We are active in the off-highway mobile marketplace, making freely programmable controllers, I/O modules, sensors, hybrid drive systems, and telematics solutions. Today we're going to be talking about the telematics solutions. So the first thing we're going to focus on is the hardware, telematics hardware. What you see in front of you is our newest telematics module called the SXTC3G. It comes in two form factors, the one on the right being one with internal antennas, and the one on the left being one with external antennas for the communication modules. If we look at the specification data sheet, we see that, I'm going to, and this is going to be fairly brief, we're just going to go over the capabilities fairly quickly for the hardware, but there's a 400 megahertz 32-bit processor, PowerPC, a gigabyte of flash memory. The basic interfaces are two CAN ports, RS-232, USB, and Ethernet. If you have the communications expansion board, you get a digital input and digital output, a 3-axis accelerometer with a wake-up function, and LEDs are visible through the housing. Also on the communications board, you can choose to have, as an option, 4 different communications modems. Bluetooth, Wi-Fi, GPS/GLONASS, which uses both systems, GPS and GLONASS, the Russian Federation satellite system, for more rapid satellite acquisition and positioning. And then the 4th communications modem is the cellular modem, the 3G, 2G modem, either in GSM or CDMA for those type of cellular systems. As far as software goes, we have the Linux operating system on board with a full board support package, including the source code, an open source development environment for maximum flexibility, and a teleservice application framework, which we will go into in much more detail here when we talk about the software. From a further hardware point of view, the TC3G is fully environmentally qualified, has a extensive temperature range from -30 to +70 degrees centigrade, and -40 to +70 degrees centigrade, and also in its internal antenna form factor is qualified to IP69K, also fully certified for vibration, shock, EMC, etc. And now we're going to talk about the controller software. One of the primary goals of STW's telematics solution is to allow full flexibility on developing telematics solutions. To that end, we provide a number of different ways for our customers to develop their applications. First of all is just by totally providing the Linux operating system, the board support package, and all of the basic mechanisms to do full independent development. So our customers can do an application totally on their own using all of the capabilities and features with help files, etc. For the TC3G. If our customers want to have more capabilities at their fingertips and don't want to develop everything themselves, then we have a number of ways that a number of pieces of software that they can use to assist them in their development. And this goes from everything from some basic, a basic framework, a telematics application framework, all the way up to off-the-shelf software components. We call this whole set of software the vehicle data system, and the graphic that you have in front of you is representation of the different components in that system that can be used by a customer to develop their applications or to run a fully functional set of applications. And we'll go into that in more detail as we go along. So the components, the basic architecture of the system is that we have the readers in the front of the system that are reading data in from the various communications interfaces. And you can see a list of network buses and the different ports and modems that are available: the CAN, RS-232, Ethernet, Wi-Fi, cellular, GPS. The readers themselves are software readers that can be configured to take data through these communications devices and then interpret them according to the protocols that apply to each individual reader. So for example, if you have CAN messages that are freestyle messages, you would use the CAN reader. If you're interfacing with J1939 engines or transmissions, other types of J1939 components, then you would use the J1939 reader. If you're interfacing with location components, GPS components, you would use the NMEA reader. Same with Isobus, same with GPS, same with CAN Open. Now these readers read any messages that coming in on these buses, and then they put the data, after interpreting it, parsing it, interpreting it, they put it into what we call our data pool. So there's a data pool daemon that is collecting all of this from the readers and putting it into the data pool itself. So the data pool is here. The data pool is simply a large memory region which is available to any application. So we're putting this data in a data pool, and it is a global memory region that any application can make use of. So any customer can develop their own applications making use of these readers, the data pool daemon, and the data pool itself. Now what we have built on top of this basic infrastructure is a whole set of capabilities that allows you to have out-of-the-box functionality. So we have up on the top a diagnostics monitoring web application that will allow you to do real-time monitoring and diagnostics. We have on the bottom a whole set of logging capabilities that allow you to develop log files and put them in a file management system and allow you to transfer them to other devices through HTTP or through the USB port. And these log files can be triggered. The logging can be triggered by events based on the various variables and data that you are reading through the readers. So that gives you a basic idea of the development environment that we have and some of the out-of-the-box functionality. We'll go into that in more detail when we look at the VDS from a web perspective, because all of this is managed and accessed through the web. But this gives you a basic idea of the architecture involved. Okay, so we have talked about how the vehicle data system can be used either to develop custom applications and use the readers and data pool to provide data to your own analytics or your own diagnostic system, or how the vehicle data system can be used as a standalone diagnostic and logging system with built-in functions already that STW provides. So anyway, here is the web application that is the basis for VDS. This web application is accessible either directly on the TC3 from a local connection through either Ethernet or a wireless LAN or Bluetooth, or it is accessible through from remote areas through cellular connections. And when it comes through some remote area, because of the nature of IT connections, it has to come through a separate server. when it's local, it's connecting directly to the TC3. So the nice thing is that both capabilities are there, and when you're going directly to the TC3, you're not going through another server, and therefore you have a much faster response time than you would in most systems, which require that use of that third party or third party server, distinct server. So anyway, here are the different menu items for setting up and using the vehicle data system. And some of these menu items are applicable to things that you would do in your own development area if you're not using the standalone functions. And some are just for the standalone or off-the-shelf applications that the VDS provides. So there is a system menu item which allows you to set up the system, configure the different network interfaces. The data menu, which is the area where you configure all your data readers for and can either configure them with individual variables for CAN variables, J1939 variables, or groups of variables, and also turn off and on the readers so that you bring in that data into the data pool. The file system, which allows you to download files that you have, basically to download log files that you have created, and then also to download error files or configuration files, ultimately, that if you want to distribute them out to other systems. The diagnostic is a real-time diagnostic. This is an off-the-shelf application that allows you to do real-time diagnostics. And then we have a series of help menus which explain the system. I should mention that the data system also contains the logging application and how do you configure that. So let's go quickly now to the system area. This tells you what your TC3 serial number is, BSP version, et cetera, and what your baud rates are in your CAN ports. Then you also find the network information just below that, both for the Wi-Fi and for the Ethernet. And you can see that the wireless LAN can be configured as either ad hoc or client, and Ethernet can be configured as DHCP or static. And here is all the information about your IP address, etc. Okay, and if you're setting up Ethernet as a static, you can actually set the values then. So that's the system and network information. Now let's go to the data area. And we'll start with the CAN reader. CAN reader, again, what you're doing here is you're saying, all right, my readers are going to go out to the various ports. This can, and typically, of course, this is going to be over a CAN port. And you have two different ports on the TC3G. And we're going to be listening for data coming in, CAN data. And we're looking for the variables that you define here. So if we look here, we've already defined certain variables. So let's take a look at one of those, pump discharge pressure. And this variable, as you can see, we've named it as described. It comes in on CAN bus 1. It has 610 as a CAN ID, so on and so forth. All the things that you need to define this variable and to be able to parse it when it comes in and correctly identify it. If I want to edit that, then I simply click on the edit key and I can edit all the different parameters. If I want to add a new variable, then I click add, and now it will allow me to specify a new variable name. So very simple. At the end of it all, you will want to save it to the TC3, and then you want to probably stop the CAN reader and start it again so that it can take advantage of this new variable. Very similar thing is in place for the J1939 reader, only instead of you defining the J1939, obviously because it's a standard, you're going to pick which PGNs and SPNs you want to use. So you can look at various PGNs. So let's pick this one, and then look at the associated SPNs and pick maybe this one. Well, let's see, disengage driveline request. Okay, now if we look at this, so this down here, it shows all of the parameters of this particular SPN so that you can have some idea what you're actually getting. And then you can add this SPN to your reader. Or you could add all the SPNs associated with this PGN if you wanted to. Now, once you've added that, then the J1939 reader will be looking for that and will bring it in and parse it and make it available for either a log or for diagnostics purposes. And it alerts you down here to make sure you save your changes to the CC3 before you leave this section. Again, you have this button here to do that. All right, so that's how you specify J1939. There's a fairly good library there already, but they're quite easy to add as well. So the new ones can be added without any problem. Okay, now let's look. The GPS reader is very straightforward. We just show you the variables that are going to be brought in if you start your GPS reader. Now, one thing I want to mention, if you look up here in this area, you have all the time an indication of what readers are actually active and which are not. So right now we have the CAN reader and the J1939 reader active, but not the GPS reader, and the logger is inactive as well. Now the next thing is the logger itself. Now the logger allows you to create a log job that is has a specific name. So there's the name. Allows you to add a timestamp, specify the maximum size, different types of file formats, the path where you're going to store that log file, the duration of the log, compression, and the rate in milliseconds, how often you're logging in milliseconds. And we'll get back to this buffered event in just a second. So that's how you define your log, and what you log is defined here. So here are all the variables that we have defined already. So these are all the variables and that are available for us to log that are not already on our log list. So as you can see, we've already put these 5 up here to be logged. Let's put a couple more up here. Okay. Now, so basically all the variables on this log list will be logged when you initiate the log job. Now, how do you initiate the log job? Well, there's 2 ways. One is either you go down and you set you turn the logger on by coming up here and saying start the logger. That's one way. Or you can have it initiated by events. So here, for example, the oil temperature. If we want to make that an event, we click on it here, and if it's an event, it's got the check mark here. So that's how you make it an event. And that now you can define how that event is triggered. You know so you have is it triggered by going over a threshold or under a threshold? So that's what the upper lower means. Is how long does it have to stay under or over that threshold? What is the value of the threshold? So on and so forth. And the same for clearing the event. So the stop, trigger delay, stop trigger value, stop timer, etc. So that's how you define the event. And then now those events will trigger the log. Now what's interesting is we have a buffer capability down here, which says how many buffers for this log. Once something is triggered, I will record the logged data for a period before that trigger occurs. So I'm keeping track of all of these log variables in a continuous way. And if an event occurs, I will actually get 5 minutes or however long you choose by the number of buffered events that before the event occurs, so that you can look at what actually caused the event. And so that's how the buffered event works. And then you can have it log for a certain period afterwards as well. So that's how logging occurs, and how all your readers occur or work. Now this configuration can be used even if you're writing your own applications for logging or for well, not for logging. The logging is an STW application, part of the VDS. So if you're configuring the logging, that is the STW logger. But if the readers can all be used by an application that you write, and you can configure them through this capability. And then you just read the data pool with some simple APIs that we provide, and you can write your own application. But this gives you all the setup necessary to define your readers and all the variables that you need. Okay, the next thing we want to talk about is the diagnostics. Now, diagnostics is a very valuable tool. Let me start off showing you a project that we already have. So diagnostics are basically real-time meters and gauges that show the variables that you're reading through your readers. And so what I have here is a pre-configured one, and we call these projects. Each set of gauges is called a project, and you can save a set of gauges as a project and name it. So here we have, as you can see, a bunch of meters, and they're different types. There's analog meters, that's what these are. There's digital meters, which is this one right here, an LED down here, and a chart. These are the 4 different types of gauges, and then you also have a label that you can use, like this system information label. So you can create any of these gauges simply by clicking on any of the gauges, then it will add a gauge for you. And then these are updated. Right now we have these being updated by a script within the TC3 that is generating canned data. And then it's looping back and being read by the readers. But so in these particular ones, we have both freestyle canned data and J1939 data being read. So for example, engine speed is, if we double click on this, is you get the configuration, and you can see that we're reading the J1939 SPN 190 for that. It's an analog value. We're calling it engine speed because that's really what it is. It has a maximum value of 8,000. So you can see that these are quite easy to configure. You just double click on them and you get all the information. You can define maximum and minimums. Their units, name them different things, and also determine whether they have decimal points associated with them. For example, on a digital gauge, you may want to put a decimal point, so you can put 1, 2, or 3 decimal points. And then also on these gauges, you can put green, yellow, and red. As you can see in a couple of these gauges, we've defined green, yellow, and red. So for this one, for example, you have green at 1, yellow at 65, and red at 85. So quite a nice capability here for these. Now, what's also great is that you filled up the screen with things. So, but you really want more gauges for this particular project. So you simply create another tab. This is where we have tab 2, and here now you can have a whole nother set of gauges. So I click on add another gauge here. Another LED here, and these are click and drag web operations, which makes them very nice to set up and put whatever way you want, and then you can save them as a project. So now in each one of these you can define as you want to. So this is a LED gauge, and you can take whatever variable you want and assign it to it. So this is very nice, and now you can have several of these tabs. So you could have a project that has 4 or 5 pages of gauges, and you can just swap very quickly between them like this. So that is a really nice feature, I think, and it gives you a lot of power. Also on this chart, you can assign multiple, you can assign 3 signals for this chart. So right now I've got pump discharge pressure. I could also do engine, well, let's say my SPN 190, which is engine speed. Now this is so high compared to, let me see. So you can see now this is the engine speed, and then this is the pump discharge pressure. So you can map several things at once, see how they vary. It's quite a nice tool for the chart. All right, I think that pretty much carries us through the diagnostics page. As I said, all of these can be saved. So you save them. You can create a project name and save them on your browser or on the TC3. Typically, you want to save them on the TC3 so that you have them available for future. But if you just want to save them locally because you're just testing them, then you would save them on your browser. Okay, and I think that's everything for the diagnostics page. The next thing I want to show you is file transfer, which allows you to go in, look at all your logs that you've created, and download all of them. Okay. Also error files and configuration files. It also has an updater, which allows you to bring in new updates to the VDS and then automatically update those, or not automatically, but when you choose to update, you update them. And you can also put your own logo rather than the STW logo on here, just by putting in a logo JPEG and updating the logo. Okay. The last thing I want to show you is the system help. So here's system, and basically the help files are all in a row here, so you can look at all of them. How each system, how each web page can be used, explanations on how to work with them. Okay, so it's a good amount of help there for reference purposes. And that is pretty much what I wanted to show you on the VDS. And we are adding functions to this all the time, and look forward to adding things here in the near future and with another video to explain it. Thanks, and please contact us with any questions you may have, and we'd love to explore your telematics needs further. Thanks. Bye-bye.